Alrighty guys, we're going to go ahead and get started with our 2D kinematic notes. So the way that I want to start off these notes is by taking a look at this simulation really quick and explaining to you guys what 2D kinematics really is. So if we take a look at this simulation really quickly, we can see that we have a cannon at a height of 14 meters, and it's going to fire a cannonball out of this cannon perfectly horizontally, meaning that the initial angle is 0, and we want to see what happens here. So if I go ahead and click fire, I'm going to slow it down, and I can see that as this cannonball makes out of the cannon, it's going to fall with a parabolic motion. What that means is that it's just curved like you can see here. You'll also notice that there's some arrows out of the cannon. This big green arrow here is talking about the total velocity, which is really just talking about the direction that this cannonball is moving at all times. You'll notice that that green arrow is changing directions, and it's also changing size as it falls. Let's take another look at it. Initially, when we fire it, it's only this long, but as it continues to go, it gets longer and longer, and the angle becomes more and more vertical. There's some other arrows that I want to look at really quick. We see this horizontal arrow, that's our X direction arrow, and this Y arrow, that's our Y velocity arrow. What do we notice about it? Well, we notice that the Y one, as it falls, gets bigger and bigger and bigger, which makes sense because as objects fall in the air, they get faster and faster and faster. But if we look at the X arrow here, we'll notice that this arrow actually does not change size. It stays the same size the entire time. The reason for that, which we'll talk about later on in the notes, is that in the air, there's nothing accelerating this ball in the X direction. The only reason this ball is falling is because of gravity, and gravity only acts in the Y direction. This is assuming that there's no air resistance, because obviously air resistance would slow it down in the X direction, but for the purpose of all of our problems, we're going to assume that air resistance does not matter. Therefore, there's no X acceleration. So now I'm going to go ahead and show the acceleration arrows, and we can see that there's only one arrow and it points down, this big yellow arrow. What do you think it is? Well, if you say gravity, you're right, because we know that gravity only points down, and we also know that gravity doesn't change, which is why this arrow is the exact same size the entire time. Alright, so now that we've taken a look at that simulation, let's go ahead and talk about how we would solve these 2D kinematic problems. The first thing we'd want to do is draw a diagram. So down below, you can see that I have a diagram of this cannon firing a cannonball off a cliff. Next, we're going to go ahead and set the origin. And we're going to say that the origin is located at the bottom of the cliff, so that would be right around here, or the ground. After we've set our origin, we can go ahead and list our variables. When dealing with these 2D horizontal problems, we should always have at least 5 known variables. And then once we've listed our 5 known variables, we should have somewhere around 4. We should remember though that anytime we're trying to solve a kinematic problem, we need at least 4 variables on either our X or the Y side to solve for the remaining unknown variables. Lastly, it's a kinematics problem, so that means that we have to solve for any unknown variables that we have using our equations. Let's take a look at our first example here. This one says that we have a cannon that is 1.17 meters above the ground, and it launches the ball 3.26 meters. It wants us to find the VOX, and VOX just means the initial velocity in the X direction. So like I said on the last slide, when dealing with 2D horizontal problems, they're almost identical to 1D problems, meaning a car that's just moving on the ground or a ball that's just falling straight down. The only difference is that now we're combining the X and the Y variables into one giant table. So over here we have all of our X variables, and over here we have all of our Y variables. So remember, we're going to go ahead and set that origin at the ground. So if we set our origin down here, this just means that we're considering the rightward direction to be our positive X, and the upward direction to be our positive Y. So if we take a look at our variables here, we can start with our distance initial in the X direction. Well, initially this cannon is located at the 0 point, so it's going to be 0 meters in the X direction. Next, we're going to go ahead and look at our final distance in the x direction. And if we look at the problem, it tells us that the ball is actually launched 3.26 meters. So over here, this is 3.26 meters from where we're starting. So I'd write final 3.26 meters. So the initial velocity in the x direction is unknown because it tells us in the problem that we're trying to figure that out. We also don't know the final velocity in the x direction. And lastly, the acceleration in the x direction. Well, like we said before when we were looking at that simulation, there's no forces acting in the x direction, and we know that net force in the x is equal to mass times acceleration. If there's no forces, then there's no acceleration, meaning that acceleration in the x direction is just 0 meters per second squared. So if we take a look at the y direction, we can see that the initial y distance is going to be the height, and it tells us that the height is 1.17 meters. And I'll go ahead and write height here so we remember that. The final y distance, well, we can see that the ball lands at the ground, meaning that our final y distance is going to be 0 meters. The initial y velocity is going to be 0 meters per second because this ball is shot horizontally out of the cannon, meaning that there's no y velocity. It would have an initial y velocity if it was being thrown down or thrown up, but it's being shot horizontally, meaning that it's only being shot in the x direction. Our final y velocity is unknown because we don't know how fast this ball is going to hit the ground here. And our acceleration in the y is just negative 9.8 meters per second squared because gravity is accelerating it in the air. Lastly, our time is also unknown because we don't know how long that ball is in the air for. So looking at our variables, we can see that we have 4 variables on the y side, meaning that we're going to use the y to start off, and we're going to start by finding out our final velocity in the y direction. Since we're missing t and final velocity, we're going to use Shaggy Cat because that only has final velocity in it. So let's go ahead and plug all of our variables into Shaggy Cat. So now we're going to go ahead and multiply the 2 over. We get negative 19.6 times 0 minus 1.17 is just negative 1.17. Multiply these together, we get 22.93. We have VF squared here, so in order to get rid of the square, we need to square root both sides, and we end up with VFY is equal to plus or minus 4.78 meters per second. But we know that this ball is going downward, and because it's going downward, it should be negative, which is why we end up with negative 4.78 meters per second. Now that we have our final velocity, we can go ahead and solve for time. If we look at our equations up here, we're looking for an equation that's missing time. That means we have big dog and little pup, but we're going to take the easier route and go ahead and use little pup. Using little pup, we get VF equals VO plus AT. Plug in our numbers. We find out that negative 4.78 divided by negative 9.8 is equal to time, and our time should be 0.49 seconds. Remember, this time is the time in the x and the time in the y. Now that we have our time, we can go ahead and solve for our initial velocity in the x direction. We can do that by using big dog, because big dog is only missing VO, where little pup is missing VO and VF, and Shaggy Cat is also missing VO and VF. So using big dog, we get 3.26 is equal to 0 plus VOX times our time, which is 0.49, plus 1/2 AT squared. We notice that A is 0, so this all just turns to 0, doesn't matter. Now we get 3.26 equals 0 plus VOX times T. Go ahead and simplify. We find out that VOX is just equal to 3.26 divided by 0.49, which gives us 6.65 meters per second. You'll notice that our final velocity is also 6.65 meters per second, and that's because acceleration in the x direction is 0. So these two will always be the same when we are in the air. And again, that's because acceleration is 0. What does 0 acceleration mean? That just means that we're moving at a constant velocity. Let's talk about some helpful tips and tricks, and then we'll call it a day. So the origin's always going to be at the ground. So in this case down here, that would be right here. We need to remember that dox, dfy, voy, and ax are always 0. And again, that just means our initial distance in the x direction is 0. Our final distance in the y direction is 0 because that's the ground. Our initial velocity in the y is 0 because we're shooting it horizontally, meaning that we're not giving it any vertical velocity, meaning that we're not throwing it downward. Our acceleration in the x is 0 because there's no forces in the x direction that are acting on it. When an object's in the air, the only force that pulls it down is gravity, and down is considered the y direction. Acceleration in that y direction, because of gravity, will always be negative 9.8 meters per second squared. DOY is always going to be our height. So anytime it says a building is blank meters tall, that's our height. That's going to be our initial distance in the y direction. So down here, if you can see this, it says 45 meters. That's talking about the height. That would be our DOY. VFY is always going to be negative because our objects are falling down. If an object's falling down, it means that it's moving in the negative direction, which means that the final velocity is always going to be negative in the y direction because down is considered negative. Our final angle, that's something more advanced, but if it asks us what angle does the object hit the ground, the way we can solve for that is using trig. And we know that the angle will equal the inverse tangent of the velocity in the y direction divided by the velocity in the x direction. It's important to note that this velocity in the y direction is always negative, meaning that our final angle will give us a negative value as well. And a negative angle is just referring to the fact that if we have an object that hits the ground here, it means that it's forming this angle with the ground, which we would consider to be a negative angle. Time in the air is only dependent on the initial height. So right here, we can see two objects, one being dropped, the red one, and then object blue being thrown horizontally. But if we notice, they both hit the ground at the same time. The reason for that is that they are starting at the same height, and the only thing that's impacting their amount of time in the air is their height and the acceleration. Since they both are being accelerated by gravity, and they both are being dropped from the same height, they will both have the same time in the air.